If a large language model could talk, would we truly understand it? This question is echoing through the world of AI and philosophy as more people interact with generative tools like ChatGPT and Claude. It's not just about whether machines think or feel. It's about what meaning even is and how these models interact with it. The focus today is not consciousness or job displacement. Those are important, but vast and speculative. Philosophy offers a grounding lens. It helps translate complex, technical ideas into something humans can relate to. In the case of LLMs, the real revolution might lie in how they generate and handle meaning. Wittgenstein once said, "If a lion could talk, we could not understand him." He meant that language is shaped by shared experience, shared life. But LLMs don't live a life. They compute. Yet somehow, they produce language that makes sense to us. That's already worth exploring. Let's start with the basics. LLMs are trained on vast amounts of text. They don't just memorize. They detect patterns. They learn to predict, to generalize, and in doing so, build internal structures that behave a lot like human language rules. Some argue that this is all superficial, just mimicry. But there's a deeper layer. These models form emergent rules that govern language use, just like how humans follow grammar rules without thinking about them. That's not trivial. That's meaningful. Take a simple example, the choice between A and an N. Humans use it automatically, based on sound, not spelling. LMs pick it up too, without ever hearing anything. They infer the rule from patterns. They don't just mimic what came before. They abstract, they apply, they extend. These rules aren't manually programmed. They emerge. A rule like A or N becomes a concept in the system, influencing lower levels of decision-making. Like a flock of birds moving together, the whole guides the parts. That's what we call emergent behavior. This emergent layer is crucial. It's not just a shortcut. It's a rich, self-organizing pattern. It tells us that meaning isn't only at the surface. It's baked into the behavior of the system. And this has big implications, not just for science, but for society. Policymakers need to understand this. If an LLM pairs the word immigrant with danger too often, it's not malicious, but it's also not random. These patterns can be audited, adjusted, and understood, but only if we acknowledge that meaning is really there, layered and active. We don't need to pretend LLMs have human-level intent. They don't, but neither should we dismiss them as mere parrots. The system doesn't just echo. It reasons within its own structure. And that structure is built from all language. To truly manage and align LLMs with human values, we need a framework that sees meaning as a dynamic force, not a static outcome. Philosophy helps here. It brings back the generalist, the thinker who connects ideas across domains. This isn't just theory. It's practical. Imagine a developer trying to fine-tune a model. A philosophical understanding of language helps interpret those model behaviors more effectively. It's not about replacing data science. It's about deepening it. Skeptics might say this is just romanticizing machines. But look at what LLMs have accomplished. They create structure, form rules, handle ambiguity, and even surprise us. These are not things a parrot does. These are marks of a conceptual system. We may be watching the rise of post-anthropomorphic intelligence, but far from being alien, LLMs are mirrors. The lion inside the machine is us. It learns from us, it speaks through us, and it teaches us something about ourselves. If you found value in this conversation, I encourage you to support our work. Your donations help us explore ideas that matter, help us keep philosophy in the AI conversation, because the meaning in machines is really the meaning in us.